Hello everyone, this is Hossein Mohit. In this video lecture, you will learn about the data manipulation with SQL. You have already had introduced to the SQL queries and some data manipulation concepts in chapter 2. However, in this chapter, you will explore more complete syntax and also dive deeper into the functions you can perform using SQL. This lecture will be slightly longer than others due to the amount of content covered. However, it is still a summary lecture. So, in order to ace in the exams and achieve a good grade in this course, you must read the chapter thoroughly and complete all the assignments and assessments. As you have learned, SQL is the name of the language used to manage and maintain database management systems. It is also pronounced as a SQL and stands for Structured Query Language. Unlike many other programming languages, SQL is not case sensitive. However, many database management systems, DBMS, offer the option to configure case sensitivity for identifiers and data values depending on your needs. White space in SQL code is only cosmetic, but it plays a crucial role in making the code easier to read. While the code will still work without proper spacing, neglecting to use white space can make it much harder to understand and maintain. Let's take a closer look at the select statement and its clauses. The select statement starts with the select keyword, which lists the columns whose values, along with any computed or literal values, will appear in the tabular result of the query. Essentially, it defines which column should be included in the output, like the one we had in the chapter 2. If the distinct keyword follows the select clause, it eliminates duplicate rows from the results, not just the duplicate value in a column. For rows to be considered duplicates, the entire row must be identical. Next, we have the from clause, which specify the tables or views from which the columns in the select clause will be drawn. Following that, we have the where clause. The where clause is used to set logical condition that must hold true for all selected rows. In other words, it ensures that only the record meeting a specific condition are included in the result set. In the where clause, you can use logical operators like and, or, and not. You can also use operators such as between to define a range in a define a range or in to check if a value exists within a set. For a string matching, you can also use the like operator can be used to just identify the patterns and is null or is not null uh, can also filter based on the presence or absence of the values. The group by clause also organize the final result based on the values of the categorical attribute, not the numerical one. This is the important point. For group by to work effectively, the attributes must contain a limited set of distinct value. For instance, you wouldn't group by age if it is stored as an integer, since it could contain many unique values. However, if age were categorized, for example, as a young or middle age or senior, you see, as a string, not as a numeric variable, you could use group by to group these categories. The other one, which is the having clause, is similar to the where clause, but applies to aggregate functions like sum or count, while where filter individual rows before aggregation, having filter aggregated results. Finally, the order by clause sort the result set in either ascending or descending order based on one or more specified column. You can list multiple columns in order by clause to sort by more than one attribute. One important thing to remember is the order of the execution in SQL query, the one that we also talk on chapter 2. Although the query is written starting with the select, the actual execution begin with the from clause to identify the source tables, followed by select clause to choose which columns, and then the where clause filter the rows and then group by organize them, having applies filter on aggregated data, and finally order by sort the output. Even though the order of the clauses in the query may differ, the system follows this execution order when processing the query. You will learn that the from clause specifies the table that should be used in the query. In the from clause, you can list multiple tables or join part of one table with part of another. Instead of using two tables independently, you can join tables in different ways to create dataset that meets your query's requirements. There are different type of joins, but most common and default type is inner join. If a join type is not explicitly mentioned in the query, it is typically assumed to be an inner join. The inner join return only the records where there is a match between the primary key and the foreign key values in both table while being joined. For example, if we have table A and table B, the inner join will return only the data where the key values match in both tables. The result set will contain only matching rows as intersection of both tables. This intersection is often represented as area C, as you see in the graph. So we call this one as a Venn diagram, which shows the overlap between table A and table B. An inner join ensures that only relevant related data from both tables is retrieved, making it a powerful way to filter and combine data. Next, we have outer joins, which are typically used when there isn't complete primary foreign key match, or when you want to include all records from one table, regardless of whether there is a matching record in other table. This is useful when you need to retain the entire content of one table and only bring matching rows from other table. There are three types of outer joins: left join, right join, and full outer join. The first one, left join. A left join returns all records from the left table, which is table A, along with the matching records from the right table, table B. If a record in the left table does not have any matching record in the right table, the result will still include the record from the left table, but the fields from the right table will contain null values. Essentially, the result will include area A, which is the records only in the left table, and area C, the matching records from both tables. If there are no matches for the left table's record in the right table, the result will still return all records from the left table, but with null value in place of the right table's field. The other one, right join table, the right join function. So a right join works the opposite way. It returns all records from the right table, table B, along with the matching records from the left table, table A. If no match is found, the fields from the left table will contain null values. This operation yields area B, records only from the right table, and area C, which is the matching record from both tables. And the last one, full outer join. A full outer join return all records from both tables. if a record from one table doesn't have a match in other table, the result will still include the records, but with null values for the missing field from the other table. This operation gives area A the left-only records, area B right-only records, and area C, which is the matching records. When performing these joins, the system creates a new memory structure, which is a temporary table in a memory that contains fields from both the left and right tables. If there is no matching data from one table, the missing value will simply be replaced with null in the output. So as we mentioned, the right outer join is similarly to the left outer join, with the only difference being that it includes all the records from the right table. It returns all the records from the right table, table B, along with only those recorded from the left table, table O, that match the primary foreign key pairs. So the result will include area B, which is the record that exists only in the right table, and area C, which is the records that exist in the matching records from both tables. If there are records in the right table that don't have a matching record in the left table, those records will still appear in the result, but as I mentioned, the fields from the left table will contain null values. The process is otherwise very similar to the left outer join, but with the rules of the table reverse. Next, we have the full outer join. So, which returns all records from both the left and the right tables, whether they match or not. It includes everything from area A, B, and C, where A and B represent the unmatched records from the left and right tables, respectively, and C represent the matching records uh, between these two tables. Any unmatched record will be paired with null values for the corresponding fields from the other table. The concept of joins, whether inner join or various outer join, can be challenging to master. It is so important. The only way to truly understand and internalized how these joins work is through only practice. Simply reading the book and listening and watching this lecture won't give you the full picture. You need to write queries as much as possible yourself, do multiple experiment with the codes, and observe the results. Joins are crucial in the real-world scenarios and are used extensively in practical data work. Whether you are a data analyst or database management specialist, having a solid grasp of how joins operate is essential for you. Without this understanding, you won't be able to efficiently manipulate or retrieve data from relational databases. So my recommendation is to read your textbook thoroughly and practice as many join queries as possible. This hands-on experience will help you to develop necessary skills and become proficient in writing effective queries. That's why for the chapter 6, we have a couple of weeks to just practice and do as much as query and coding as much as possible. Union. Union is another kind of operation, but unlike joins, it does not combine two tables directly. Instead, it merged the result of two select statements into a single result set. For union to work, the select statements must have the same number of columns, and the data types of the corresponding columns must match or be compatible. If the column differ, the union operation will not function correctly. So that's the important point. If the columns differ, the union operation will not function correctly. There are several types of union operation. The simple union, which combines all the records from both queries. The second one, the except one, The xout operation returns all records from the first query while excluding any matching records from the second one. And the intersect, the third one, returns only those records that are present in both query results. The syntax works like this. The select statement from list of the columns, and within the select, you can also apply some conditions. It can complete select statement followed by union keyword, as you can see in the codes in this slide. And then the next select statement, you can use it in order to join with the previous select column with the union keyword. Another important thing is SQL functions. SQL functions are similar to mathematical functions in that they can take an input and produce some sort of output or result. These functions will always return a result unless the input does not meet their specific requirements. Here are some simple examples. The upper function converts all characters in the string or in a text to the uppercase. And also the other one, the len, len function returns the length of the string. For example, the len George will return 6 because there are 6 characters in the name, in the George name. This function can be used in a select or where clauses to help achieve the desired output. Each database management system comes with its own set of built-in functions, and the available functions can vary between systems. For instance, some functions available in Oracle might not be available in SQL Server, or they may use different keywords or syntax. For this reason, it's important to consult the documentation of the specific DBMS you are using. Additionally, most DBMSs uh, allow user to create custom functions for for special purposes. Functions can also be divided into the scalar function and aggregate functions. So scalar functions operates on just individual rows, while aggregate functions work on a set of rows, such as sum, count, or AVG average. For more comprehensive list of common functions, especially those specific to the MySQL, the one that we are using, you need to make sure to review the relevant chapter in the textbook. Here are some additional examples of how functions are written and used in SQL. For instance, the month function extract the month part of from the given date. So if you have a date like January 1st, 2017, the month function will return 1 or 01. Similarly, the day function extracts the day from a date, and the year function extracts the year. The other function, getDate, retrieves the current date and time from the server's clock system. Let's look at the example query. Suppose we want to retrieve all sales that occurred between October and December of the previous year. So the query would be written as select asterisk from the sale where month of the sale date between 10 and 12, and the year sale date plus 1 equal to year get date. Let me tell you what does it mean. In this query, we will use the month parenthesis sale date function to extract the month from each sale date, ensuring that only those from October to 12, which is 10 October to December, which is 10 to 12, are included. The year getDate function extract the current year from the system's date. To filter the previous year's sale, we compare the year of each sale using year sale date plus 1 equal to year getDate. This ensures that the query only retrieves all sales from the October to December in the year before the current one, before the one that we are here right now. These type of queries, combining month, year, and get date functions, are useful when filtering record based on the specific time frame. The group by clause is used to calculate the aggregate value for a column or calculated attribute across set of groups. For example, the query select category AVG or average of the list price as average list price from product group by category. This query select the category column and applies the AVG function, which is the average function, to the list price column, naming the result as the average list price. It retrieves the data from the product table and groups the result by the category column. The group by clause defines the field or attributes on which DBMS will build the groups. As mentioned earlier, the field used in the group by clause should be categorical. It cannot be numerical. For instance, if the field is age stored as an integer, it won't work properly because each integer would because each integer value would become its own group. In aggregate query like this, all fields in the select clause must either contain aggregate functions such as the AVG list price or appear in a group by clauses such as category. If any additional columns were included in the select clause, they would also need to be either part of the group by clause or use the aggregate functions. The having clause is used to restrict the group that are returned in the results of query. For example, we want to select the product categories with more than $10,000 in total sales. In the select statement, we select the category column or attributes, then use the aggregate functions, use sum functions, which sums the quantity multiplied by the sale price. And we name it as a total sales, which this value saved as a total sales. The data comes from the product table, aliased as a P, and it is joined with the sale item table, aliased as a SI. And it's using the product ID. The product ID is the primary key in the product table and a foreign key in the sale item table. So the results are grouped by category, and then we introduce the having clause at the last line. The condition in the having clause is that the sum of quantity multiplied by sale price, the one that we referred it as a total sale, must be greater than $10,000. Instead of repeating the aggregate function, we can use the alias as a total sale. We can use the alias total sales. To understand the having clause better, you should refer to the book and practice the example provided. So this chapter contains many different syntaxes and their associated context. So it's in order to learn better, it is crucial to practice continuously. You, as I mentioned, you have more than usual normal time for this chapter because mastering the syntax and concept takes time for this chapter. So it requires to write and running several queries using the having clauses. It is important to know the difference between the where and having clauses as well. The where clause tests values in individual rows and it's applied before the having clause. On the other side, the having clause tests values or counts on the groups formed by aggregate function. So as seen in this example, the condition in the having clause apply to the results of the sum function within the select statements. Now it's time to dive into the more complex queries known as subqueries. Subqueries are essentially queries within a query, often referred as a nested queries. They can be embedded inside the select, from, where, or having clauses of a main query. Subqueries must always be enclosed in parentheses, and they must contain at least select and from clauses. However, they can also include other clauses such as where, group by, or having. In fact, subqueries can become quite complex and act as a complete queries on their own. The ability to use subqueries allow you to perform more advanced operations, such as retrieving data based on the conditions that are determined dynamically from another query. Let's explore subqueries in more detail. Subqueries most often appear in the where clause because the where clause execute early in the query process. So the results from the where clause uh, are used to help to solve the rest of the query. When you place a subquery within the where clause, the outcome of the subquery will be used to determine the result of the outer query. Subqueries can either be dependent or independent of the outer query. Dependent subqueries rely on the same table or fields used in the outer query, while independent subqueries use different table or fields. Subqueries are often used to generate a single value or set of values that fit into the where clause. In many cases, subqueries can be used as an alternative to joins. Whether to use joins or subqueries, it depends on what you find easier to work with. Some people feel more comfortable using the subqueries because they can relate better to that logic. Some people prefer use joins for achieving the same outcome. So the choice between joins and subqueries depends on which approach help you visualize and achieve the result uh, you need more effectively. It's different between them. And you will see many examples of subqueries in your book. And just like with the other SQL concepts, mastering them require practice. You need to experiment with writing subqueries, make mistake as much as possible, and then learn from them. There is no substitute way in order to learn. You just need to use this hand-on practice, and uh, as long as you practice more, you can find it more meaningful for you. For sure, now you might be a little confused, and this is normal. But again, by watching this video is not enough to learn. You need to go through the book and practice as much as possible in the next few weeks that we have for next couple of weeks that we have for this chapter, chapter 6. Then we have the correlated subqueries, also known as a dependent subqueries. These occur when within the where clause and cannot be executed independently because they rely on the current row from outer query to execute the inner query. Let's walk through the example of the correlated subquery. Imagine you need to list employees who were hired before their supervisor. Do you remember the employee table that has a recursive relationship with itself, meaning that each employee can also act as a supervisor? For this query to work, this subquery must identify the supervisor ID for each employee from the outer query to determine if the employee's hire date is earlier than the supervisor's. Here's how it works. The outer query select last name, which is the optional. We could use the first name. We just use the last name from the employee table. The condition in the where clause check if the hire date of an employee is less than the hire date obtained by the subquery. The subquery select the hire date from the same employee table but only for the row that where the employee ID matches the manager ID of the current employee in the outer query. So when the query runs, SQL make, this is so important, SQL makes two copies of the employee table, one for the outer query and give the alias of E for that employee. As you can see, we have select last name from employee and the alias is E. And one for the inner query given the alias S for the supervisor. So for each row in the outer query, which is table E, SQL check the conditions in the where clause. However, the condition is based on the subquery, which select the higher date from the inner queries version of the employee table, which that employee table this time is S, where the employee ID matches the manager ID of the employee in the outer query, which is E table. In this type of queries, aliases are essential to distinguish between the two versions of the same table being used. Without proper aliases, uh, the system wouldn't be able to differentiate between the rows from the outer and the inner queries. This is the key feature of the correlated subqueries. They depend on the value from the outer query, making them more complex but powerful for certain type of tasks. Now let's take a look at the subqueries in the select clause. When we use the subquery in the select clause, we are identifying a new column to be selected. It is best to use the as keywords to name that new column, make it easier to reference them later. The subquery may return a single value that repeats for all rows in the query results, or it may return different values for each row if it is correlated with the current row of the outer query. Similar to subqueries in the where clause, subqueries in the select clause can be either dependent or independent. If they are dependent, you will need to use different aliases for the same table in both the outer and inner queries. Here as an example that we want to list all products along with the average list price of all products. The query would be select asterisk, select average of the list price from the product table as average list price from the product. In this query, the subquery inside the select clause calculate the average list price from the product table. This value will appear as a new column called average list price for every row in the result. Since this is the simple subquery, there is no need to use aliases. However, for more complex subqueries involving the same table in both the inner and outer queries, using aliases is necessary to avoid confusion and ensure the query runs correctly. Now let's take a look at the subqueries in the from clause. You know that the from clause defines the table that will be used in the query. Subqueries in the from clause are used to create a table or set of records for the outer query. An example is listing all customers along with the number of sales for each customer using subquery in the from clause. So here how it works. We select first name, last name, and number of transactions from the customer table, which is joined within the result of the subquery. The subquery selects the customer ID and counts the number of sales, which is from the sale ID, for each customer, grouping the result by customer ID. This subquery is given an alias, such as a sales summary and uh, such as uh, sale summary. So when we perform the join, we join the comment field. In this case, the customer ID to link the outer customer table with the result of the subquery. So here, how the query looks like. So we have the select first name, last name, number of transactions from the customer. Join the inner one, select customer ID, count sale ID as a number of transactions from the sale group by customer ID as a sum query. And on customer from the customer ID from the customer table and customer ID from the sum query. The outer queries select the customer name and the number of transactions from the customer table with the transaction counts provided by the subquery. This way, each customer is listed along with the number of sales associated with with them. So this might feel a bit, I know this might a little bit complicated to grasp just from the lecture, but again, to fully understand subqueries and do well in this course, especially in your second exam, you need to practice writing subqueries from the book and experiment the different variations. You need to make mistake as much as possible and then learn. The more you practice, the better you will understand how you can work with these queries. Now let's move on to the SQL for data manipulation. You have already seen some of these SQL codes and syntax in chapter 2, but here you will learn more about them in detail. Uh, the three important operation is insert, update, and delete. So the insert, this operation adds new records into a table. It allows you to populate the table with fresh data. The update, this one modifies existing records in the table. It can change a specific field based on the condition you define, enabling you to keep the data up to date. And the last but not the least, delete. This one removes record from the table based on certain conditions. It ensures that the obsolete or incorrect data, outdated data or incorrect data can be removed from the database. So each of these operations play an important role in maintaining and managing the data within your database, making them essential tools for effective database management. The insert clause or insert statement can either copy record from one table into a new one or add the record to an existing table. To copy records from one table into the new table, we can use the select into followed by the name of the table, the new name of the new table name, and then specify the old table and any condition using the where. To add records to the existing table, we can insert one record at a time by specifying the fields and the order in which value are inserted. For example, we use the insert into followed by the table name and then list of the fields or attributes to insert values into the table, and finally provide the values in the same order as the fields or attributes that are listed already. This method is commonly used in transactional operational databases, such as uh, point of sale, for example, where every sale must be recorded in the database immediately. Alternatively, if we want to insert values based on the fields, based on the field or order, based on the field that order by table schema, we don't need to specify the table name. We can simply write insert into followed by the table name, values along with the values in the same order as the table schema. Additionally, we can also insert multiple records at once using a subquery. In this case, the syntax would be insert into followed by table name within the subquery using the select from a statement. The subquery can also be more complex if needed. allowing for advanced data insertion. So this approach allows you to select data from the source table and insert it into the existing table seamlessly. So the update statement will update all records in the table unless a where condition is specified to determine which records should be updated. So here's how it works in a general. We use update followed by table name, then set to assign a new value to a field. For example, you can change the field name by specifying the set with a new name. So followed by a where clause to identify which record should be updated. If no where condition is provided, all records in the table will be updated. It is important to use this with caution to avoid unintended changes to the database. Similarly, the delete statement remove all record from the table unless a where condition is used to specify which record should be deleted. Both update and delete are designed to work on multiple records or a specific group of records, not just individual values. It is important. Each record may contain multiple values across fields or columns that exist in your table. The general form of the delete statement is delete from followed by the table name and then the where condition to specify which records to delete. It is important to be cautious when using the delete, especially if the primary key of the table being modified is referenced as a foreign key in other table. Deleting records without considering referential integrity can lead to issue and disrupt the relationship between table. At the end, let's talk about the views. A view is just a temporary table, essentially a window into the portion of your database. It is not a copy of your database table, but rather a temporary structure. Once created, it can be used just like the table and will behave as one. So you can write queries on views uh, the same way that you do on tables. However, before using a view, you first need to create it. Views are useful for facilitating businesses operations and reporting, providing more focused structures that align with analytical needs rather than just a raw database schema. Additionally, views can be used to restrict access to the underlying tables, enhancing security. You can design your database system so that the updates are first applied to views, which in turn update the actual tables. This adds an extra layer of security and controlled access to your data. Reports are always based on queries, and if you generate frequent reports, views can help streamline the process. To create a view, you use the create view keyword, followed by name of the view, and then after the view name, you use the uh, as keyword, followed by the select statement that defines the data that the view will contain. Any query, including those with subqueries, can be used within the select statement to define a view. So querying a view is just like querying a table. You use the select followed by the field name, then from, and instead of specifying a table name, you provide a view name. You can also perform joins and use subqueries on views in order to have the same way that you use for the tables. Okay, so this was a short summary of the chapter 6, and as you already noticed, it's a kinds of complicated chapter, so you need to practice as much as possible. So it covers the SQL statement for querying, data manipulation, and database maintenances. So as I mentioned earlier, this chapter requires a lot of practice. Fortunately, you have plenty of opportunities to do that with the exercises in your book. So just please don't be afraid to make mistakes. Make as many as you can, make as many as you need until you truly understand and master these concepts. There is no other way to become proficient in SQL and especially querying and data manipulation. Only things is just practicing regularly. If you want to confident in SQL, and if you want to put it in your resume to show that you are proficient in SQL, you need to definitely just practice in order to potentially landing a job by just a SQL skill. And for sure, you need time to invest in this area. So just take this one as an opportunity to practice, learn, and develop your skill. And good luck.